Okay, now let's take a look at the second problem that we could have with this particular relationship. Let's say that we want to find our v sub I when we know our delta x and we know our acceleration, which is equal again to g, which is equal to our negative 9.81 meters per second squared, and we know our delta t. So we'll go delta t equals some value in seconds. Okay, let's fix our squared here for a moment. Okay, we're going to find v sub I in meters per second when we know our delta x, or displacement, our acceleration, and our time. So the first thing we have to pay attention to is where is the variable that we're trying to solve for. In this case, v sub I. And unlike our first case, delta x, we have to do some algebra before we can solve for v sub I. So after doing the checklist, focus on what you have to find and then isolate that variable using basic algebra technique. Okay, to do that, we have delta x equals v sub I plus delta t plus 1/2 a delta t squared. And we note that if we want to isolate the term for the initial velocity, the first thing we would have to do would be to subtract 1/2 a delta t squared from both sides so that we would have a term left on the right that only had v sub I delta t. So the next step would be simply subtract 1/2 a delta t squared from each side. That would leave us with the following result. Delta x minus 1/2 a delta t squared would then equal the initial velocity, v sub I, times the time, delta t. Sometimes students do a silly algebra mistake by trying to immediately divide by the initial velocity. But as you can see from this example, and as you would recall from your basic algebra days, you couldn't do this because of that 1/2 a delta t squared having been added to the original quantity here. So be careful, watch that you do your add subtract rule before you try the multiply divide rule to isolate v sub I in cases like this. So you'll notice we have a new equation and there's one more step. V sub I is not yet isolated, i.e. it is not by itself, so we simply have to do what? Divide both sides by the delta t, and we would get the following result. The delta t's basically cancel out on the side where v sub I is located and gives us our final relationship where v sub I equals delta x minus 1/2 a delta t squared all over delta t. Now all we would have to do is take the values that we have for delta x, a, and delta t and calculate our final answer, avoiding, of course, that digital error caused by that leading digit off the end of our hand and the buttons on a calculator. You're ready to do this one. Now we'll investigate the rest of the options.